The PQ method is a way of factoring trinomial expressions, tri meaning 3, where we have the form ax squared plus bx plus c, where the a is 1, or I should say, whatever is in front of the x squared. In this case, it'd be 1x squared. Now, we normally don't put 1x squared, we just put x squared. Now, when we're doing this, basically what we're doing is we are going to make sure that we factor it based on these numbers. For example, y equals x squared plus 7x plus 12. My a is 1, it'd be 1x squared. And like I said, we don't put a 1 there normally, but we assume it is there if it's just x squared. B is 7x, so my b is 7, and then my c is 12. And as I said, does my equal 1? Yes, it does. So now we can factor it. There's ax squared plus bx plus c, which in this case is x squared plus 7x plus 12, into two separate binomial expressions, x plus p and x plus q, where the p and q are whole numbers. Now, got the expression up here, x squared plus 7x plus 12. Again, my a is 1, my b is 7, my c is 12. Our first step is developing a table. On the left side of this table, on the header, I put p times q in the left column. And on the right, I put p plus q in the right column. Now, this we have to pay close attention here. My original trinomial equation, y equals x squared plus 7x plus 12, my p times q has to equal 12. I got an arrow pointing here. But this same p times q over here has got to equal this right here. And then my p plus q has got to equal 7. We'll go to the next page and I'll show you what this all means. Again, my expression x squared plus 7x plus 12. I've set up my two tables here. P times q equals 12, and then p plus q equals 7. And that 12 comes from the c in my trinomial equation, and that 7 comes from the b, as I pointed out. On the left side, where I have p times q equals 12, I'm going to put all the factors, when multiplied together, come up to 12. I like going the first number from lowest to highest so I can keep track of everything. 1 times 12 equals 12. 2 times 6 equals 12. I was going to put a few in here. 3 times 4 equals 12. And then we got, you can't forget, negative 1 times negative 12 equals 12, because negative times negative is a positive. We got 2 times negative 6 equals 12. That's a terrible 12, by the way, and negative 12, but I think you get the idea. All these equal 12, and then negative 3 times negative 4 equals 12. So these are all the possible factors that will multiply together become 12. Now step 4. What I'm going to do here is all those factors I've put in. 1 times 12, 2 times 6, 3 times 4. I'm going to add those two numbers together. 1 over here plus 12, that equals 13. 2 plus 6, that equals 8. 3 plus 4 equals 7. Negative 1 plus negative 12 is negative 13. Negative 2 plus negative 6 is negative 8. Negative 3 plus negative 4 is negative 7. Now, what we need to do here is find the equations that where the p times q equals 12 and the p plus q equals 7. Now on the left, of course, they all equal 12, but there's only one on the right that equals 7. This one right here, 3 times 4. So it's two factors, my 3 and my 4. Now, as I've shown you before, I've circled this. This is much neater, so it's not writing on this. P times Q, 3 times 4 equals 12. And my P plus Q equals 7. Again, that's 3 times 4 is my C. That's where that came from. And my 3 plus 4 is my B, which is 7. Those two numbers can now are my P and Q. So when I factor out x squared plus 7x plus 12 using the PQ method, I have, this bringing those numbers down. It'd be x plus 3 times x plus 4.